Hi there, Joshua here. I was teaching angles to my class, and this kid said to me, she said, how many degrees are there? How many degrees are there in a maths teacher's CV? I said, all right, at this school, one if you're lucky. Let's get on with the lesson. Welcome to this lesson on advanced trigonometry. So what I'm going to be doing in this lesson is I'm going to be talking about sine, cos and tan for all angles. So not just angles in triangles, not just angles less than 180 degrees, but for all angles as you go round and round a circle. So to draw angles in this topic, we use what's called a quadrant diagram. So it's a diagram with 4 quadrants. This is the first quadrant, the second quadrant, the third quadrant and the fourth quadrant. And angles are measured from this horizontal line going anti-clockwise round, so going round this way. So this would be 90, this would be 180 degrees, 270 degrees, 360 degrees, and you can keep going round, 450, 540, 630 and so on. You can even talk about negative angles by going the other way, by going clockwise. So from here, this would be minus 90, minus 180, minus 270, minus 360 and so on. So let's just do a few examples of marking some angles on the diagram. So how would you show 30 degrees on the diagram? So 30 degrees. I'm just going to do a sketch, I'm not going to do it accurately, I'm not going to measure it. But where would 30 degrees be roughly? Well, 30 degrees is between 0 and 90, so it's maybe there roughly. So that's 30 degrees. It's in the first quadrant. What about 115 degrees? That's an obtuse angle, so where's that going to be? 115 degrees. We always measure from this horizontal line, and for positive angles you go anti-clockwise, so that's 90, and it's 25 degrees on from that, so it might be somewhere over there roughly, so perhaps there, that would be 115 degrees. So it's an obtuse angle in the second quadrant. Let's do a reflex angle, let's do 240 degrees, 240, so where's that going to be? Well, again measuring from this horizontal line, you go anti-clockwise, so 90, 180, 270 is too much, so 180 was here, and 240 is 60 degrees on from that, so it's maybe roughly there. So that would be 240. So it's a reflex angle in the third quadrant. Let's do another reflex angle, let's do, I don't know, 320 degrees. 320, where's that going to be? 0, 90, 180, 270, that's 360. 320 is nearly a full turn, but it's just 40 below 360, so maybe somewhere there roughly. So that's 320, so it's a reflex angle in the fourth quadrant. Like I said, you can talk about negative angles by going the other way, by going clockwise round. So for example, let's say we wanted to mark minus 50 on the diagram. Where's that going to be? Well, again, you always start from here, but this time you go clockwise for negative angles, so minus 50 would be between 0 and minus 90, so it may be there roughly. That would be minus 50. So that's a negative angle, and it's in the fourth quadrant. Let's do another negative one. Let's do minus 120. Where's that going to be? Minus 120, well that's 0, and that's minus 90, and it's just 30 degrees on from that, so maybe about there. So this would be minus 120 degrees. And you can also do angles bigger than 360, you can keep going round and round. So let's do 380. 380. How would I show that on the diagram? Well, starting here, 360 would be one full turn, and then 380 is 20 degrees more than that, so it's a bit more than a full turn, so maybe there roughly. So to show it, I guess I could do that. It's 1 and a bit turns, so that's 380 degrees in the first quadrant there. And let's just do one more, let's do 630. 630. How would I mark that on the diagram? Well, again, 360 is a full turn, and then that's 450, 540, 630. So it's there. It's exactly 1 3/4 turns round. So I guess I could show it like that. That's 630, 1 3/4 turns round. So that is how you mark angles on this diagram. Right, so now I'm going to talk about sine, cos and tan for all different angles. So I'll start with an acute angle. So I'll just draw an acute angle, and I'll do it roughly over there. So it's between 0 and 90. It's an acute angle. Remember, you always go from this horizontal line. I'll call it theta. And to talk about sine, cos and tan for this angle, I need to form a right angled triangle. So what you do is you drop a line down to the horizontal axis. You always go to the horizontal axis, and you've got a right angled triangle now. And suppose when I measured these sides, let's just suppose this side was 4, this side was 3, and this side was 5. The units are irrelevant, could be centimetres, could be inches, doesn't really matter. I'm just choosing numbers that work in Pythagoras' theorem. So how do we talk about sine, cos and tan for this angle theta? Well, we can use SOHCAHTOA, if you remember. SOHCAHTOA, that just tells us what sine, cos and tan mean. So for example, sine theta means opposite divided by hypotenuse, and so on. So we need to label the sides opposite, adjacent and hypotenuse. Well, the hypotenuse is just the longest side, so this is the hypotenuse, and the opposite and the adjacent are the shorter sides. The adjacent side is next to this angle, so it's that one there, it's at the base, and the opposite side is opposite the angle, so that's the 3, that's like the height. And now we can just write down sine theta, cos theta and tan theta. So sine theta is just the opposite divided by the hypotenuse, so it's the ratio of these two sides, so it's 3 over 5. Cos theta is adjacent divided by hypotenuse, which is 4/5, 4 over 5, and tan theta is opposite divided by adjacent, which is 3 over 4. And you can extend this idea to all other angles. So let's do an angle bigger than 90, let's do an obtuse angle. So always starting from here, so that's 90, let's keep going into the second quadrant, so let's say there. Again, I'll call this angle theta, but this time it's an obtuse angle. An obtuse angle. Again, to sort of talk about sine, cos and tan, I need to form a right angled triangle, and you always drop a line down to the horizontal to get your right angled triangle. And suppose when I measured the sides, let's just suppose this side was 6, this side was 8, and this side was 10. If I want to write down sine theta, cos theta, tan theta, I need to label the sides, hypotenuse, adjacent and opposite. Well, the hypotenuse is always the longest side. Now notice the angle is actually outside the triangle, but we still talk about the opposite and the adjacent relative to this angle, relative to the angle in the triangle at the centre of the quadrant diagram. So this will still be the adjacent, and this will still be the opposite side. So the adjacent is always the base, and the opposite side is always the height of the triangle. And I need to point out at this stage that if the adjacent side or the opposite side are going left or down, they're actually treated as negative numbers. So the adjacent is going to the left, so it's treated as -6. The opposite side is going up, so it's treated as a positive number, so that's treated as +8. The hypotenuse is always treated as a positive number, whether it's sloping that way or whether it's sloping that way. So the hypotenuse is always positive, but the opposite and the adjacent could be negative if they're going left or down. So now we can write down sine theta, cos theta and tan theta for this angle. So sine theta, again it's just opposite over hypotenuse, so 8 over 10. Cos theta is adjacent over hypotenuse, which is -6 over 10. So cos theta is negative. And tan theta is opposite over adjacent. So tan theta is 8 over -6. And I'll just bring the minus sign to the front, so it's -8 over 6, -8/6. So notice if the angle's in the second quadrant, cos and tan will be negative. Right, let's do a reflex angle now. So I'll do an angle in the third quadrant, so that's 90, 180. I'll go a bit further, I'll go to here. So here theta is reflex. Reflex. Now to form the right angled triangle, this time you go up to the horizontal. So you always go to the horizontal, but this time you need to go up to get your right angled triangle. And let's suppose I measured these sides, and this side was 5, this side was 12, and this side was 13. Let's label them hyp, op and adj. So the hypotenuse is the longest side. The adjacent side is the side next to this angle here. This is the adjacent, and the opposite side is the angle opposite. It's the side opposite this angle here. So this is the opposite side. Now, as I said, if the adjacent's going left or if the opposite side is going down, they're treated as negative numbers. The adjacent is going to the left, so we treat it as minus 12. The opposite side is going down, so we treat it as minus 5. The hypotenuse is always taken to be a positive number, whichever way it's sloping. So in the third quadrant, the adjacent side and the opposite sides are negative. So right, let's write down sine theta, cos theta and tan theta for this reflex angle. So sine theta is opposite over hypotenuse, so it's minus 5 over 13. Cos theta is adjacent over hypotenuse, so it's minus 12 over 13. And tan theta is opposite over adjacent, which is minus 5 over minus 12. The negatives cancel out, so that's also the same as 5 over 12. Right, so let's do another reflex angle. Let's do an angle in the fourth quadrant now. So let's go all the way around to there. So here theta again is reflex, it's in the fourth quadrant. Again, to form our right angle triangle, you need to drop a line to the horizontal. We'll draw it up. And let's suppose I measured these sides, and this side was 3, this side was 4, and this side was 5. So I'm just using 3, 4, 5 again. I'm always using numbers that make right angle triangles that work in Pythagoras' theorem. So let's label the sides. So this side's the hypotenuse. The adjacent side is next to the angle here. So this is the adjacent, and this side is the opposite side. Now notice the adjacent side's going to the right, so we treat it as a positive number, but the opposite side's going down, so we treat it as a negative number. So sine theta is opposite over hypotenuse, so it's minus 3/5. Cos theta is adjacent over hypotenuse, so it's 4/5. And tan theta is opposite over adjacent, which is minus 3/4, minus 3 over 4. Let's just do a couple more. Let's do a negative angle. So just do it down here. So to do negative angles, remember you have to go clockwise round from this horizontal line. So let's do an angle between 0 and minus 90. Let's just do it over here, let's say. So theta, so it's in the fourth quadrant, but theta is negative here. It's negative here. So to form the right angle triangle, again you go to the horizontal, like that. And suppose I measured these sides and I found that this side was 9, this side was 12, and this side was 15. Again, I'm just using numbers that work in Pythagoras' theorem. So let's label them hype, op and edge. So, well, it's the same situation as that one really, isn't it? This is the hype, this is the adjacent, this is the opposite, and the opposite's going down, so it's treated as a negative number. The adjacent's going to the right, so that's positive. So we can straight away write down sine theta, cos theta and tan theta now. So sine theta is opposite over hypotenuse, minus 9 over 12. Sorry, minus 9 over 15. So cos theta for this negative angle is adjacent over hypotenuse, 12 over 15. So it's positive. And tan theta is opposite over adjacent, so it's minus 9 over 12. Minus 9 over 12. So that's sine, cos and tan there for a negative angle. Let's just do one more angle. Let's do an angle bigger than 360. So I'm going to go round a full turn, a full 360 degrees, and a tiny bit more. So it's an angle in the first quadrant, but I've gone around 360 and a bit more. It looks about 400 from the way I've drawn it, but it's a bit bigger than 360. Drop a line down, form a right angle triangle. And let's suppose when I measured the sides, this length was 8, this length was 10, and this length was 6. Let's label the sides hype, op and edge. So the hypotenuse is the longest side, as always. So this is the opposite side, and this is the adjacent side. Again, I'll call the angle theta. So theta, and here theta is greater than 360. But you define sine, cos and tan in exactly the same way. So let's try and fit it in over here. So sine theta is the opposite side over the hypotenuse. Oh yeah, the adjacent and the hypotenuse, sorry. The adjacent and the opposite are going right and up, so they're both treated as positive numbers. So sine theta is opposite over hypotenuse, which is 6 over 10. Cos theta is adjacent over hypotenuse, which is 8 over 10. And tan theta is opposite over adjacent, which is 6 over 8. So if the angle's in the first quadrant, everything's positive. So that is how you talk about sine, cos and tan for all angles. Right, so I've got a couple of questions that relate now to what we've just done. Question 1, for each of the diagrams, you've got an angle drawn, and you've got to work out sine theta, cos theta and tan theta. So for each angle, I've actually drawn the triangles, but there's a side missing. So what you need to do is you need to use Pythagoras to find the missing side, and then using SOHCAHTOA you can write down sine theta, cos theta and tan theta. So if you look at the first one, over here, it's an acute angle. It's just in the first quadrant, it's acute. And but I haven't given you the hypotenuse. It's unknown for the moment. The opposite side is 3 and the adjacent side is 7. So let's work out the hypotenuse using Pythagoras, and then we'll be able to write down sine theta, cos theta and tan theta using SOHCAHTOA. Well, using Pythagoras, this side squared is just that squared plus that squared. So 7 squared is 49, 3 squared is 9, 49 plus 9 is 58. So the hypotenuse is just the square root of 58, so root 58. So now we can write down sine theta, cos theta and tan theta. Sine theta is opposite over hypotenuse, which is 3 over root 58. I could simplify this fraction by rationalising the denominator, but I'm just going to leave it like this. Cos theta is adjacent over hypotenuse, which is 7 over root 58. 7 over root 58, and tan theta is opposite over adjacent, which is 3 over 7. 3 over 7. Right, let's move on to part B, this angle here. This angle here is nearly a full turn. It's a reflex angle in the fourth quadrant. So it's reflex. And again, there's one side of the triangle missing, the adjacent side, because we've got the hypotenuse side. The hypotenuse here, the opposite side there is 1. The adjacent side, to work that out, that's one of the shorter sides. So you need to do that squared, take away that squared equals that squared, and then square root. So 5 squared is 25, 1 squared is 1. 25 take away 1 is 24. So the adjacent side is just the square root of 24. And the adjacent side is going to the right, so we treat it as a positive. But the opposite side is going down, so we'll actually treat that as a negative number, minus 1. And now we can write down sine theta, cos theta and tan theta. So sine theta opposite over hypotenuse is just minus 1 over 5, minus a fifth. Cos theta is adjacent over hypotenuse, so it's root 24 over 5, root 24 over 5. And tan theta is opposite over adjacent, so it's minus 1 over root 24. Minus 1 over root 24. Well, let's move on to the third one over here. This angle is actually a negative angle because it's been drawn in a clockwise direction. It's somewhere between minus 90 and minus 180. So it's negative, it's a negative angle. Not that it really matters for the question. And again, it's the hypotenuse that's missing. The hypotenuse hasn't been given. The opposite side is 4, the adjacent side is 6. So we can work out the hypotenuse again using Pythagoras. 6 squared plus 4 squared is 36 plus 16, which is 52. So the hypotenuse is root 52. The adjacent side is going to the left, so we treat that as a negative. The opposite side is going down, so we treat that as a negative. Sine theta is opposite over hypotenuse. So that's just minus 4 over root 52. Cos theta is adjacent over hypotenuse, which is minus 6 over root 52. And tan theta is opposite over adjacent, which is minus 4 over minus 6. Minus 4 over minus 6, which is the same as 4/6. The negative signs sort of cancel each other out. Or you could even simplify it to 2/3. Right, let's move on to these two questions down here. So the first one, it says sine theta equals 2/5. Theta is obtuse. Find cos theta and tan theta. So we've been told sine theta is 2/5. We've been given that. We've got to find cos theta and tan theta. We've also been told that theta is an obtuse angle, which means it's somewhere between somewhere between 90 and 180. So it's between 90 and 180. So it's got to be in the second quadrant. So I'll just mark it in there, in the second quadrant over there. Drop a line down, form the triangle. I'll label the sides as well. We've got the hypotenuse, got the opposite, got the adjacent. And we're told that sine theta is 2/5. Sine is just opposite over hypotenuse. So it's telling us that the opposite side divided by the hypotenuse is 2/5. In other words, the ratio of this side to this side is 2 to 5. So we could just say that this side is 2 units long and this side is 5 units long, because that divided by that is 2/5. So now we have to do is find the adjacent side from these numbers. So we can use Pythagoras' theorem. 5 squared is 25, 2 squared is 4, 25 take away 4 is 21. So the adjacent side is root 21. And because the adjacent side is going to the left, we treat it as a negative number, minus root 21. The opposite side is going up, so we treat it as a positive number. So now we're ready to answer the question. We can say what cos theta is and what tan theta is. So cos theta, tan theta. Well, cos theta is just adjacent over hypotenuse, so it's minus root 21 over 5. Minus root 21 over 5. And tan theta is opposite over adjacent, so that's 2 over minus root 21. So 2 over minus root 21. And I'll just bring the minus sign to the front, so it's the same as minus 2 over root 21. Right, let's move on to the last question now. Similar sort of question. It says cos theta is minus 5/7. Theta is reflex. Find sine theta and tan theta. So this time they've given us cos theta. We've got to find sine theta and tan theta. Now we've been told theta is a reflex angle. That means it's somewhere between 180 and 360, so it could be in the third quadrant or in the fourth quadrant. But we've been told that cos theta is negative, minus 5/7. Cos, if you remember, is adjacent divided by hypotenuse. The only way for cos to be negative is if the adjacent side is negative, because the hypotenuse can't be negative. So is the adjacent side negative for angles here or for angles here? Well, it's for angles here in the third quadrant, because the base, the adjacent side is going to the left. In the fourth quadrant, the adjacent side is going to the right, so it would be positive. So if the angle's reflex and cos theta is negative, then it must be in the third quadrant, because the adjacent side's got to be negative. So let's draw an angle in the third quadrant. So there we go. Theta, I'll drop a line up and I'll label the sides. The hypotenuse is this one. This is the adjacent, this is the opposite side. Now cos theta is minus 5/7. Cos is adjacent over hypotenuse. So ignoring sines, that basically means that the ratio of adjacent to hypotenuse is 5 to 7. So we could say that the adjacent side is 5 units long, again ignoring its direction, and the hypotenuse is 7 units long. We will treat that as minus 5, but its length is 5 and that length is 7 there. And now we could find the opposite side. So again, just using Pythagoras, 7 squared is 49, 5 squared is 25, 49 take away 25 is 24. So the opposite side is just root 24. Root 24. And the adjacent side is going to the left, so it's negative, and the opposite side is going down, so that's also treated as a negative number. So now we can answer the question. We can say what sine theta is and what tan theta is. So it's sine theta and tan theta. So sine theta is just opposite over hypotenuse, so that's just minus root 24 over 7. Minus root 24 over 7. And tan theta is opposite over adjacent, so that's just minus root 24 over minus 5. Minus root 24 over minus 5. And the negative signs sort of cancel each other out, so that's the same as root 24 over 5. Right, for the last part of the lesson, what I thought I'd do is I thought I'd work out sine, cos and tan for some actual known angles, so for some actual numerical angles, rather than just theta every time. So I've drawn a triangle in the quadrant diagram over here, and I've marked an angle from the horizontal. This length is 2, this length is 1. Now it's actually possible to work out this angle just from looking at the diagram. So what is that angle? That's right, it's 30 degrees. Now actually that's not very easy to spot. The reason it is 30 is because, well, one way to show it is to reflect this triangle down. If you reflect the triangle down, you actually get an equilateral triangle where all the sides are 2, and all the angles in an equilateral triangle are 60 degrees. And since this is basically an equilateral triangle that's been cut in half, that's why the angle is 30 degrees. So we can actually use this picture to work out sine, cos and tan of 30 degrees. So the hypotenuse is 2, the opposite side is 1. We just need to find the adjacent side. We can do that with Pythagoras. So 2 squared is 4, 1 squared is 1. 4 take away 1 is 3, which means the adjacent side is root 3. And both the adjacent side and the opposite sides are treated as positive numbers because they're going right and up. So we can work out sine, cos and tan of 30 now. I won't write them all down, I'll just do maybe sine 30. Let's just do sine 30. So using SOHCAHTOA, sine 30 is opposite over hypotenuse, which is a half. So sine 30 is a half. You can check that on the calculator, it is a half. Now you can actually use this triangle, this diagram, to work out sine, cos and tan of lots of other angles, all related to 30 degrees, by reflecting the triangle across, or reflecting the triangle down, or rotating the triangle. For example, how can we reflect this triangle to work out sine, cos and tan of 150 degrees? So how can we use that diagram to work out sine, cos and tan of 150 degrees? Well, let's think where 150 is on the quadrant diagram. So remember, you always measure from here. So 150 would be in the second quadrant, somewhere over here. How far away from 180 is it? Well, it's 30 away from 180. So this gap would be 30. This would be 150 from the horizontal. So we can actually just reflect that triangle across, and then we'd have a triangle for working out sine, cos and tan of 150. So if we reflect that triangle across, then this will be 1, this will be root 3, this will be 2. So this angle would be 150, and this is the hypotenuse, the adjacent, the opposite. So the adjacent's going to the left, so we treat it as a negative number. The opposite's going up, so we treat that as a positive number. The hypotenuse is always positive. So we could work out sine, cos and tan of 150 from this picture. Again, I won't write them all down, I'll just do cos 150. So what's cos 150? Well, it's adjacent over hypotenuse, so it's minus root 3 over 2. That's cos 150. Let's do a couple more angles. So how could we use either of these diagrams to get sine, cos and tan of 210 degrees? Possibly by reflection. How could we get sine, cos and tan of 210 degrees using these triangles? Well, again, let's think where 210 is on the quadrant diagram. Where is 210? 210 is a bit beyond 180. It's 30 on from 180. It's in the third quadrant. So this will be a gap of 30. And this would be 210 degrees. So how could I draw a triangle to help me? Oh, well, I could just reflect this triangle down. I could reflect this one down, like so. 1, root 3, 2, just ignoring signs for now. And now I've got a triangle to help me work out sine, cos and tan of 210. I've got the hypotenuse here, the opposite here, the adjacent here. This is negative, this is because it's going left, this is negative because it's going down. So now I can work out sine, cos and tan of 210. Again, I won't do them all. I've done sine, I've done cos. I'll do tan of 210. Tan of 210 is just opposite over adjacent, so it's just minus 1 over minus root 3. So minus 1 over minus root 3, opposite over adjacent. The minus signs cancel each other out, so it's the same as 1 over root 3. Now, how could I use these diagrams to work out sine, cos and tan of minus 30? How could I use, maybe look at the original picture, so how could I maybe reflect that to get sine, cos and tan of minus 30? Well, minus 30 is just 30 degrees measured the other way, so I just need to reflect that triangle down, really. because minus 30 is just over here. So minus 30 is 30 degrees the other way. So if I reflect that triangle down, then I'll have a picture for working out sine, cos and tan of minus 30. This would be 1, this would be 2, this would be root 3. So this is the hypotenuse, this is the adjacent, this is the opposite side, and the opposite side is going down, so we treat it as a negative, we treat it as minus 1. The adjacent side is going to the right, so we treat it as a positive number. So we could work out sine, cos and tan of minus 30. Again, I won't write them all down. I'll just do, we've done sine, cos, tan, so I'll do sine again. Sine of minus 30 is opposite over hypotenuse, so it's minus a half. Sine of minus 30 is minus a half. Right, let's do 2 more to finish off. Let's do 330. So could we use any of these pictures to work out sine, cos and tan of 330 degrees? Well, 330 is almost a full turn. It's 30 away from 360. So which picture could we use for that? We could actually just use this picture, because this line, it's 30 degrees clockwise from the horizontal, but if you go anti-clockwise, it's 330 degrees round. So it's 30 away from 360, so that is 330 degrees anti-clockwise from the horizontal. So we could actually use exactly the same triangle for sine, cos and tan of 330. We could just use this triangle. So let's do, again I won't do them all, let's just do cos 330. So cos 330 is adjacent over hypotenuse, so it's root 3 over 2. So sine, cos and tan of minus 30 is the same as sine, cos and tan of 330. Right, last one to finish. How could we use, let's do sine, cos and tan of 390. So how could we use any of these pictures to work out sine, cos and tan of 390? Well, 390 is just 360 plus another 30. So we could actually use the original picture, because this line is 30 degrees round from the horizontal, but it's also 390 degrees round if you do a full turn and then 30. So if you do 360 and then 30, you could say this line is 390 round from the horizontal, 360 plus an extra 30. So you could use this triangle to work out sine, cos and tan of 390. So let's just do tan of 390. So tan of 390, using this triangle, is opposite over adjacent, so it's just 1 over root 3. So sine, cos and tan of 30 and sine, cos and tan of 390 are the same. That's it. Right, so that's the end of the lesson. So I am going to do another lesson on this topic, on the quadrant diagram. But in the next lesson, all the triangles that I draw are going to be inside a circle of radius 1. So I'm going to draw every triangle inside a circle of radius 1, called the unit circle. And if you do that, it means the hypotenuse will always be 1. And by making the hypotenuse 1, it makes it much easier to picture sine, cos and tan. Because to work out sine, cos and tan, you don't have to do this divided by this or this divided by this. You can just sort of look at the picture and you can immediately see what sine theta is, what cos theta is and what tan theta is. So it's a much nicer way of picturing sine, cos and tan if you do it inside a circle. You've probably got no idea what I'm talking about, but it will make sense next lesson. So what I'm going to do now is I'm going to put some questions on the board for anyone who wants to practice what we've done today. And you can have a go at those. I'm also going to put the answers at the very end of the video, so you can pause the video, have a go at the questions, and then look at the answers in that order. Right, here are the questions. Bye.